Hello, guys. I haven't made a video in quite some time. I was on vacation. I went back, and I thought I was going to talk about making a React Native SDK today. So last week, a client got in touch with me because they wanted to make their SDK available to React Native apps. Um, so I thought at the beginning this was not a very complex topic, but then as I was talking with the developers, I realized that it might actually be not that simple, right? If you're not embedded in the React Native world, if you're not working with it, and you just have your own company where you have developed an SDK, some sort of service, you don't really know how React Native works, you don't know the pros and the cons. You are also probably having a native SDK, so you have Java developers or Android developers and iOS developers who might not know React, right? So you might attempt to create first purely React components, or you might not be sure what's a good API, and so on and so forth. So some of these questions that for me seem very basic are actually not that basic, right? So I thought I would make a video explaining some of the pros and the cons and how you can um, create your SDK or create bindings for your SDK from a very high level perspective. I might show you a little bit of code, maybe not. We'll see how it goes. But hopefully, if you are a company and you are trying to make your SDK available to React Native, this might help you at least guide yourself in the initial implementation. And then if you need help, you can always get in touch with me or some other React Native experts in the community. They should be able to help you with the more detailed implementation. Good. So the first thing I want to touch base upon is very high level, which is the API design. So if you have your SDK um, developed for iOS or Android, you're probably attaching it to the way the platform itself is working, right? So if you are doing this on iOS, you might your documentation might tell the developer on application did finish launching. You should add a little bit of snippet so you can initialize the SDK, maybe pass an API key or something like that. On Android, it will also land in the specific Java class. Um, I think that's fairly straightforward, right? But there are more complex use cases. So, for example, where you might want to present a screen to the user. So let's say your SDK takes care of authenticating the user somehow, or registering the user with your service, or maybe getting the payment information from the user. So in this case, it's not quite as straightforward to realize how are you going to do this. The mistake that I saw with this client was that they were trying to make their entire SDK a mountable React component, which might work for certain use cases. So for example, if you want to have an embedded view or you want to take over the entire UI of the application, that might be a good way to do it, or it's just an option. But sometimes you might not even need that, right? So let's say there are three ways where you can expose your API. The first one would be expose function. The second would be promise or callback. Let's call this a listener as well. And finally, a React component. So each one of these has, let's say, a more specific use case. Let's call this a sync function just to make it more clear. Right, so a sync function, you can think the most basic use case for this as your SDK.init and I don't know, maybe an API key, right? I think this is very straightforward. Your SDK needs to be called with an API key so it can talk to a server, it can verify or authenticate the user, whatever, right? And then this will return an instance of your SDK that maybe has some other methods afterwards that the user can use. So you might have something like your SDK track point, whatever, right? So your user or your developer will need to first initialize the SDK and then call the API. What I think is not very straightforward if you are not aware of the architecture of React Native is that these calls can not only be programmatic calls, you can actually interact with the UI, right? So a good example of this would be authentication SDK, right? So let's say I'm just calling this auth0 because it seems fairly popular nowadays. And let's say auth0, you first initialize it, you have an API key. And then what you could also do with auth0 is say authenticate. You probably have an enum somewhere in there, some methods, email, something like this, right? So let's say you have your React Native app in here. The first init call is not going to do, it's not going to have any UI reflection, right? The user might not be aware that the SDK has been initialized, but this authenticate call, it can take over the entire application, right? So let's say this is your app, you have some text in here, things are running. And when you call this function, what you can do in your native code is create another view or another activity and just overlap it with the React activity, right? So React runs or React Native runs is a subcomponent of a view or an activity, right? And if your native SDK implements another activity, you can just overlay it, right? You can just put something in front of it. So then the SDK takes over the life cycle of the application. Right? So you call this, and then however you have defined your transitions. Um, it might be a sheet that comes on top. It might pop up or whatever, right? And then you're inside of your SDK thingy, right? So here you will ask the user for the email and the password, and so on and so forth, and the user will then press OK, and this will be dismissed, and you can return. You will return to. Can I undo this? Yes. You will return to the normal flow of the application that was there before, but now your user will be authenticated. Um, this is the most common, or this is the easiest pattern, so to say, right? So some SDKs are perfectly suited for this. So let's say authentication or maybe banking, somewhere where you just need to get some information from the user, and then you return all the information to the application where the SDK is being integrated. Now these are sync functions. You can also do this via promise, callback, or slash listener. Right? So if you do this as a completely sync method, then the app will block, right? So if your entire SDK is done in a native component, then your activity will be fine, but you will block the entire JavaScript thread. And so what you probably want to do is this in an async manner, right? So you have auth0, authenticate. So you have the call to authenticate. It's pretty much the same, but you will allow the JavaScript thread to keep running, so the React Native application can still do things in the background while the user is authenticated. This is with a promise. Another pattern that's used in some of the React Native libraries is via listeners, right? So instead of having a promise return, you first do something like auth0 on, uh, let's say on user changed, right? And this takes a callback where your SDK will pass a user object. It might be null if no user has been detected, but the React Native developer can react to this, right? So first you call authenticate. It might be a promise, it might not be. You don't really care, right? But this immediately returns So the JavaScript thread is running, and then when the user has interacted with your SDK, then the callback will be called. And it's the job of the React Native developer to react to these changes, save some state, save some token, whatever you have given to them. So these are two ways. Um, you can see that both can interact with the UI, but you really need to take over the entire UI that you present to the user. There is a third use case where you might say, okay, I don't want to take over the entire React Native application, right? Because my SDK, I only need to show a little bit of information, but I don't, my developer, the people who are integrating the SDK, they need to be able to still control the UI. They might want some theming, they want to change some colors. So you still want to give them, you don't want to take over the application, right? So in those cases, what you really want is to create or to expose certain parts of your SDK or of your views of your activities as React components so that they can be mounted on the JavaScript side. Right. So here, what you would say is something like login, or let's say auth0, let's say auth0 login form, right? And your login form might take a theme object, um, might take callback, maybe. It depends. That this is a little bit more complicated, um, but it will be something like this, right? So then the developer can or will be able to take over or will be able to embed this login form in whatever way they see fit, right? So maybe they put it on the top, on the bottom, on a different screen, whatever, right? Um, so these are basically the three ways, the three important concepts that you need to handle, right? So you don't want to do everything in a React component because then you might run into the issue of render cycles, right? So if you put it in the render method, it will immediately get mounted. That might not be the flow that the user wants, right? They might want to wait for a little bit until they manually call and they say, okay, now I'm sure that the user wants to trigger this authentication call or whatever. So each one of them has their use cases. Good. Um, the second point we need to touch base is on the old bridge versus the turbo modules or JSI. Again, this is one of the things that if you are not part of the React Native community, you're just starting to reading up on it, it's not completely clear. For seasoned developers, this fairly obvious. So you have the old bridge and you have JSI turbo modules. So the old bridge. The old bridge is based on JSON serialization, right? So you have the communication between the JavaScript. You might want to call a native function. That call will be, or when you call this function and whatever data you pass gets serialized to JSON, reaches to the native side. Kotlin, Java, Swift, Objective-C, doesn't really matter. Do the computation, serialize it back, goes to the JavaScript side of things. JSI is based on C++. So you have your JavaScript code that gets boxed into C++ um, objects, which can interact with Objective-C or with Kotlin, Java. It's entire pipeline there, but it basically skips the serialization cost. So it's order of magnitude faster. That's all you need to know. Like I can go very deeply in the technical part, but you probably don't care, right? Like your company is not mainly a React Native company. You just want to make your SDK available to the users. So from your perspective, what are the advantages and disadvantages? The disadvantage of the old bridge is that it's slow, mainly, right? But here we need to talk about it's not black and white, right? So for example, if you have a method called init where you take an API key, right? You're basically going to serialize a very tiny amount of data, like an API key, so fairly small string, send it once, and then kind of forget about it, right? So the cost of this, depending on how busy the JavaScript thread is, but let's say, fairly optimistically, um, it will be around 5 milliseconds. The turbo module versions for this very same call will probably be 1 millisecond. It's even less than, it's in nanoseconds, right? What is the problem? The problem is the JSI, if you're writing pure JSI, you need to write C++, and it's very complicated if you're not a React Native developer because you need to understand a lot of the architecture. Turbo modules make this a little bit faster, but in my opinion, it also has drawbacks because code generation, in my opinion, is never a good idea. You always reach into edge cases where you have to generate even more code and you generate more complex DSL to express what you want to achieve. Doesn't matter. But let's say um, you still have a little bit of cost of writing turbo modules. Might not be as complex, but it's there. Whereas the old bridge, it's a little simpler to write because it's based on macros, right? So here you have the DSL, which is some sort of TypeScript plus that you will need to learn. And here you have the macros, which are fairly easy. So in my opinion, is if your SDK only has calls like this, right? Like small thing goes over the bridge, you don't need to worry too much about sending too much data back and forth. I would stick with the old bridge just because the implementation is easier. Maybe it will go away at some point, and then at that point we will all have to jump into turbo modules. But for now, it's fine, right? Like the performance cost is not that much. Now, where you might want to opt for JSI in the turbo modules is when you're sending a lot of data back and forward, right? So let's say you have a query method, right? And this query method will return, I don't know, 3,000 objects, right? Like 3,000 JSON objects, each with n fields, 2, 3 fields, it doesn't really matter, right? Like once you starting to count objects in the hundreds or the thousands, and let's say you will populate a list, and the user or the developer will have to take this data, put it into a list. This is where it really gets slow because of the serialization, right? So this might take 100 milliseconds. If your app is not doing that much, worst case scenario, it might take 300 milliseconds, right? Or let's say half a second. So then you really have a big performance hit. And if you constantly need to refresh this list, then it will start to get slow, right? There's where you really want to go for turbo modules. You will have to write a lot more logic, so to say, to box whatever value you have from Swift or from Java, Kotlin into the C++ things if you're writing pure JSI. If you're writing turbo modules, you might be tricked into thinking, okay, I'm just returning Objective-C or Java values like integers, floating points, and this kind of stuff. And you might think, okay, this is not really what happens, right? Like turbo modules is also a wrapper around the C++ boxing values. So there's still some conversion going on. That being said, it's nowhere near as expensive as it is, right? So let's say maybe here it will take 10 milliseconds. It's hard to say. It depends on the data you're sending, on the how much conversion is there, if you have strings, etc., etc. But this is orders of magnitude faster, right? So here's where you will have to make a decision. If your SDK consists of simple API calls, I would recommend stick to the old bridge. It's easier to write. You don't need to worry too much about all the complexities of C++ and turbo modules, yada, yada, yada. You just write your code and it will work just fine. If you're sending a lot of data back and forth, then you really need to look into the JSI or turbo modules. Good. The last thing I want to touch upon is dependencies. So this is not necessarily a problem with React Native, but mostly about the JavaScript space, right? So again, your company is probably not a JavaScript company or not too interested in JavaScript and the web ecosystem. You have developed your SDK, your native SDK. You just want to publish your thing, right? So one of the questions I had with this client, which was fairly interesting, was if they can publish their files into npm, right? Like if you have never worked with npm, this is a very valid question. You don't know how the build system works. Short answer is yes. You can just put whatever you want in npm, it will get downloaded, right? So um, let's say you have your SDK. If you use any of the templates out there, you will have a iOS folder, you will have an Android folder, you will get a bunch of files, you will get an index.js, you will get a pod spec. I don't remember who it was. It's the pod spec file, right? So basically, you just so there are many options. Like always, you can do a lot of things. So one of the options you have is doing your or embedding your source or sources, right? So here you will have SDK file one. Maybe you did it in Swift, or whatever, right? It will just go into the iOS folder. You have to follow the documentation, how to create your native modules, how to expose the bindings into React Native. But it doesn't really matter, right? Like you just put your files in there, and your pod spec will contain the definition of what files need to be compiled, right? So at some point you will see on the pod spec there's a source files thingy which contains something like .swift, right? So your pod spec is telling Xcode, um, just takes just take everything that it's with a Swift ending, just compile it, and then through the magic of Xcode, everything will be linked together. You don't need to worry about it, right? So when you publish this into npm, your Swift file will be there, and the users don't need to extra download some source files or whatever, right? So this is embedding. Every time the user compiles their app, they will also compile your SDK, and everything will be available. Everything will be linked together. Now, the other alternative is doing artifacts, right? So let's say you have a Rust library, and all you need to do, and let's take Rust as an example, right? So you need to compile Rust for iOS, for Android. This is independent of React Native or Xcode. When you compile your library, you just need to set the correct target, the correct format. But let's say the Rust compiler will give you .m file and is it an M file? No, it's probably going to be like the binary file and or the library and a header file, right? So this is also fine. You can also do this, right? Once this both have been compiled on the source files, you will also probably have to add a .h and um, whatever whatever needs to be done for Rust to embed your library. Right? So let's say this is I don't remember right now whatever format is dilib, I think it is for iOS. Um, so then you have your source files, and then you will probably have a I don't remember how is it for the pod file, but let's say embedded files, and then you will also say just put the dilib in there. No, I don't remember how it's. I think it's dependency. Yeah, probably something like this, right? You just say SDK one file dilib, right? So Cocoa Pods will take care of finding this file and setting it as a dependency of your project, so it will also be available to the link. For Android, it will probably be something similar. Of course, not a dilate, but whatever Android uses. And for Android, you will have to do it with the build.gradle file. So you have some Java specific stuff in there, and the build.gradle, you also have to declare, okay, this file needs to be linked on compilation time so the users can access your SDK. For Android, you can also use AARs. If you are a more seasoned Java developer, you know what an AAR is. You basically take your library and you compile it again as a library, but this is more specific for Android. Again, you only need to mess a little bit with the build.gradle, tell it where it can find the AAR files in order to link them, but it's not a problem. You can also do that. Now, one very interesting question I wasn't expecting was Swift Package Manager versus Cocoa Pod. So the current, if you are a native iOS developer, the current recommendation by Apple is to use the Swift Package Manager. So there's one way to make this work, which is basically instead of embedding your files inside of your React Native SDK, you first go to Xcode and you add your Swift Package Manager dependency there, right? So what it will do, Swift Package Manager will download the source files or maybe also the pre-built library. It will download it for you and then it will link it to your project. So basically, you're not going to be embedding your native SDK from your source files for npm from CocoaPods, but rather it will kind of live separately yet in the same project, right? So you have to tell your developer or the developer that's integrating your SDK, okay, first you have to go into the Swift Package Manager, set this dependency, it will be downloaded, then install our SDK from npm, and through the magic of Xcode, everything will be linked together, right? So you can make this work. It's just cumbersome. I wouldn't recommend that you do this because it's not the way of doing things in the React Native world. In the React Native world, you want to publish everything to Cocoa Pods, right? So whatever that means for your SDK, Cocoa Pods has some requirements. You just have to go through the process, publish it on Cocoa Pods, and once it's there, what you would say basically is dependency, my SDK and whatever name you have. You have published that on the CocoaPods repository or registry. You would just declare it, and then CocoaPods will take care of bringing that. And on your source files, you just have your bindings for your SDK for the dependency that you have created. Okay, I wanted to go a little bit over the code, but I don't think it's necessary. This is just very high level stuff. I would basically show you the documentation on how to create a binding. I wouldn't show you anything too interesting, too new, right? So these are the important parts. If you want to create single functions, some functions with promises or callbacks, React components, everything in each one of these you can just find in the documentation, and you have to read it, understand a little bit how turbo modules work, how the old bindings work, how the code is generated, and so on and so forth. You have talked a little bit about the pros and the cons, about the old bridge and the turbo modules, and about the structure of your files. Okay, I hope you find this very high level video useful. And remember, I'm available for freelance work. So if you need anything, you can just contact me through my email, ospfranco@protonmail.com. And yeah, I hope you're having a good day.